And we are live. Let me lower the music a bit. Hey everyone, how are you doing? Today we're gonna continue working on my lure turner. And let me get rid of this because it's super hot. Okay, so where did we left out the last time? I think what I wanted to do was to model everything, see how it looks. So we're gonna model the motor. We're also going to model the socket. We might model these two parts here. I'm not sure yet. We'll see. What else do we need to do? We are going to... We'll see if we have enough time. We might get rid of this and find a better way to connect two or more of these pieces together. And I'm using a new mouse today, so I hope everything goes smoothly. It's a bit loud though. Anyways. Yeah, so I guess I'm gonna start with the motor because this is like the most important thing. And oh, come on, I need to get used to the new mouse. So I need to pull up I think I need to log in to AliExpress so I can check Let's see, it should be quick. You will see my orders. Okay. Okay, where's the motor? The motor, here it is. So we're gonna get the dimensions. Should be here somewhere. Okay. So here are the dimensions. We know L. I think it was 12 volt, 7 speed. So L is 29 mil. So this is 29 mil, 23 mil. The diameter back here is 33. In the front it's 37. Should be easy to model. Let's see, where do we put it though? I think it's in the motor holder params. Motor diameter 37. Distance between screws. Okay, so we need to add a couple of stuff here, like gearbox length, for example. This one is, how much was it? 29, I think. Yeah, 29. So gearbox length is 29. Huh, this is lagging a bit. Screw diameter, motor holder thickness. So we can move stuff outside of this. I think that would be the ultimate way to go. So create a new spreadsheet, call it motor. Now we should, moving platform params, we should move some stuff here, like, I guess, come on, delete this. Yeah, you see this spreadsheet is lagging. It's probably affecting too much. That's why it's lagging. So we should probably move some stuff, but I'm gonna leave them for now. So the motor diameter is gonna be here. Motor diameter, what else do we need? Let's see. So this is already in a spreadsheet. I think this is already in a spreadsheet. This 6 mil, I don't think. Screw diameter 3. Interesting, what is this? Oh, okay. That's for these screws. Distance between screws. Okay, motor pin offset. Motor offset from top. Motor holder thickness and pin diameter. I think that was, I got it from here somewhere. It was 10 or, oh, it was 12. Interesting. I have it as 10. This should be 12. Anyways, I'm gonna close this and start adding stuff here. So let's move this up. Gearbox length. It's gonna be this. Go back up. We're gonna call this, what do we wanna call this? Let's say electronic box length. Ooh, sorry, my bad. That's here. And let's give this a capital letter to stay consistent. This one is 23. Give it an alias. What else do we have? The diameter of the electronic box is 33. So electronic box diameter 33. Again, we need to give this an alias. We have the pin, I think we called it pin holder. We have the diameter. Let's call this one thickness or length. So the pin holder length is 6 mil. What else do we have? We have pin length, that is 15 mil. And we have the pin diameter is 6. Anything else? 6 mil. No, I think that's it. $15.5. What? This is 15. Here it says 15.5. Anyways, that is fine. So now we need to, first of all, let me assign alias to these values. Pin diameter, this is small I. Okay. Nice. Okay. By the way, one thing I learned recently is in part design, you can't, not only you can add new bodies, but apparently you can create a part that will hold multiple bodies, and this is super useful. I wish I knew it earlier, because for example, let's say here I want to move everything inside this electronic box away from this object right here by a certain tolerance. So instead of every time moving these objects away by a tolerance and then the amount that I actually want to add, I could have created a part, moved the entire part, and then create bodies inside of it. So basically they will share an origin that we can transform, which is super helpful, but I didn't do that. So so for now we're just gonna deal with this mess, but that's fine. In the next project I'll keep that in mind. So as you can see here, for example, when I created this body, if we look down here, this is the z-axis. I want it to be here. So if I had a part created, then that would have been done for me automatically, because I would have moved the entire part. But for now, let's move this by general.tolerance in the y direction, and now it should be okay, negative, not so minus y.tolerance. Okay, now it's here, and now we want to move it up here. So in the z direction, we need to go by general.height, I think, minus come on, what was it? Motor holder params, motor diameter divided by 2 minus motor holder params dot offset from top, and we should be right in the center. Let's hide all of these because we're not using them. Lure holder, I think that's, yeah, we want to hide the lure holder, hide the screw, hide the bearings, hide the moving platform, and why not hide the base plate. Okay, cool. So now we're at the back. Let's also hide the motor holder. Cool. come on. What's going on? This new mouse that I'm trying. Is it the mouse or is it the program? Anyways. So now we are going to create a sketch on the XY plane. Okay, this should be better now. Oops. Yeah. Cool. So we're gonna start with the gearbox, and then we're gonna do the rest. So the gearbox, we know the diameter of it. That's gonna be the motor holder params dot motor diameter. That's the old value that I was using for 37, right? Yeah, 37. That's why it's in a different spreadsheet, but that's fine. Okay, so we need to pad it backwards with the gearbox length. So we're gonna pad, reverse it, and we're gonna get this from motor. Oh, wait. Okay. I forgot to rename this to motor params, because this body actually is going to be called motor. Cool. Now we're going to pad, reverse, and we're going to get the motor params dot gearbox length. Cool. So that's our gearbox. And for now, let's hide the box just so we can see. So now we need to, let me get this here. It's easier for me. So now we need to model this part right here. I'm gonna call it like electronic box or something. To do that, I need to draw on this face. So let's show the origin, create a datum plane, attach it to this face, and in the Z direction we need to go minus, again, motor params dot, what was it called? Gearbox length. Cool. So now on the datum plane, let's create a sketch. Toggle this. What is this called? I keep forgetting it. View section. And now let's constrain the diameter to motor params dot electronic box diameter. Cool. And now we're gonna pad this in reverse. Motor params dot electronic box length. Nice. Now this should be it, but we do have two more things at the back. We have this little notch and then these two, what do we call them? Wire pins? Let's call them wire pins. Let's do the front first and then we'll get back to these wire pins. So we have what is called, I think we named this, oh man, I keep going in the wrong direction. I think we named this pin holder in our motor holder params. Motor holder thickness? No. Pin holder diameter and the pin offset. Yeah, these are the two. Pin holder diameter and pin offset. And in our motor params, we have the pin holder length. It's a bit of a mess at the moment, but that's fine. So I'm gonna make a sketch on the YZ plane. And we need to draw a circle here at the top because we have an offset. And this offset is motor holder params dot motor pin offset, and this one right here is going to be our holder params dot motor or pin holder diameter. Okay, close. And now we need to pad it by motor params dot pin holder length. Cool. Cool. What else? Now we need to create the actual pin. So I'm going to create a datum plane, attach it to XY, and in the Z direction, motor params, okay. Pin holder length. Okay, cool. Need to do something similar. So again, we have an offset here. We get it from motor holder params dot motor pin offset, and we get this from motor params dot pin diameter, and then we pad it by motor params dot pin length. Cool. So that's our motor. Let's bring back the electronic box to see how it looks, and also motor holder, something like this. And let me see, this is nice. This is the cutout we created last time. It fits nicely in here. Hopefully it's not a snug fit. It shouldn't be, because 0.2 mil, I set our tolerance to 0.2 mil, so it should be free to spin. Oops, sorry. Yeah, what else? Yeah, the things at the back. So let's hide again the motor holder and the electronic box, and we need to put these two here at the back just for scale, just to see what's like the interior of the electronic box, how it looks like, to get an idea. We're gonna call these wire, let's call them wire pin width, wire pin length, and let's do a wire pin thickness. So let's make them 2 mil pins. They're not actual pins. I don't know what they're called, to be honest. I'm just gonna call them pin. This looks like I don't know, 8 mil, because this is 6. I think that's about like 8 or 10 mil. I'm gonna exaggerate it, so 10 mil. And then for the width, I'm gonna set it like 4 or 5. I'm gonna measure the actual values when I get the actual thing, but for this specific thing that we're modeling at the moment, it doesn't actually matter. This is just a visual thing, so we're fine. Let's see our datum planes. We have one here, so what we can do is we can create a new datum plane, attach it to the old one, and then here go by minus motor params dot electronic box length to get to this face right here. Cool. So what we need to do now is we're gonna model one of them, and then we will mirror it. So I'm gonna do it up here, even though in the actual motor, it's gonna be a bit, it's not like at the top, it's off center. It's like somewhere here, but that's fine. So we need an offset. I think we need an offset. Let's call this wire pin offset. Let's do 4. We can change it if it doesn't look right. And this offset is gonna be from here to the center. I'm going to take the motor params dot electronic box diameter divided by 2, because from here to here it's a radius. And then I'm going to remove that offset. I had a typo. Okay, 12, cool, nice. So now we have I think this will be the length. Let's call this motor params dot wire pin length. This will be, no, wait. That's gonna be the width, sorry. Motor, oh, come on, what's wrong with you, FreeCAD? Yes, width and thickness is what we want. So here we're looking for width, and here we want the wire motor params dot wire pin thickness. It does not look right, but anyways, we're going to we can change it whenever we want. So reverse it, and now we need the motor params dot wire pin length. Cool. Now to mirror this, I think we can just, yeah, we can use the XY plane to mirror it. So I'm gonna select it, create a mirror, and choose the XY plane and click OK. Cool. So that's our motor. And this is getting trippy. Nice. Let's show the electronic box now. So we do have space. We do have enough space. We're gonna have the fan down here, which I'm not very happy about. I think it should be close to the motor, right? So we might, so this is currently blowing air right on the on this part right here. If I can move it up till maybe right here, then we're gonna have air blowing on the motor and then some air blowing down here. I mean, we're not gonna have too much heat. All of these are like very low wattage stuff. But yeah, I think we can get away with reducing the width of this. So we can go to motor holder params. No, not motor holder params, the electronic box params. And we can change this. Let's try 100. See how it looks. Yeah. That's probably not good, right? Because we want to attach something here, so we need some space. I think I'm gonna leave it at 120. It's gonna be fine. Now one thing I can do is move this down, but if I move it down, we're not gonna have enough space for this unless we do it vertically. That could be an option. So we move the power supply down. And flip the power supply, of course, so the wires are at the top. And then we can take this and model it vertically instead of horizontally. That could save us some space. But I mean, this is not a huge box. This motor is not that big, and this power supply is not that big. So even though it might look big at the moment, it's not big actually. Yeah, let's move the fans. So the fans, how did I do them? Fan offset, fan width, fan length, fan height, offset from motor. What did I mean by that? Let's see, 5. Oh, okay. Okay, it doesn't make sense, but let's keep it at 10. But where am I setting the distance from top? Fan hole diameter. This is interesting. Electronic box, pocket, sketch. No, that's not the sketch I'm looking for. Might be this one. Okay, what is this? Oh, okay. That's not good. I divided by 2. No. Okay, so we're gonna add a new parameter here. Let's call it fan offset from top, and let's give it a value of 40, for example. Perico, welcome to the live stream. Why you don't take the motor of the old device and attach the fan just behind? Good question, because I was going for a simple solution, and then we got carried away. And someone in my Discord actually showed a prototype of a lure turner using this motor right here. Where is it? This motor. So this is a high torque motor. It could handle more weight, basically. If you put like lots of lures on it, it could handle them easily. And one more thing is we can connect to it. Where is it? Somewhere here. We can connect to it something like this, which controls the speed. So you have this, where is it? Yeah. So we have this knob right here where you can like increase the speed or decrease it, which is super nice. So what's gonna happen is we're gonna mount this. So this is the board right here. It's gonna be here. And then we're gonna mount the switch up here to reverse it. If you wanna if you want it clockwise or counterclockwise, you can control it by a switch in here. And then this hole will have a knob, so you can increase the speed and decrease it. That's why we went for this. It was cool. Now it's gonna get a bit more pricey, but I mean it's not a big amount. So maybe I'll make later another version that's a lot more simpler than this. I'll see. But for now, this is what we're doing. Anyways, what did we do here? Offset from top, fan. By the way, let me know what you think about this. If you like the idea or not. Okay, so we're gonna go height minus the thickness minus electronic box params dot fan offset from top, and another typo here. Okay, so this is where our fan will be, and then we can control it using this. So for example, 50, it's gonna move down, and 40, it's gonna move up. Whoa, it's gonna be the super lure turner, the definitive one. Yes, it's gonna be the super lure turner. Like, to be honest, I was thinking about even making it. Oh, wait. I think for this one, I just need to move. Oh, no. I need to do a couple. Is it this sketch? No. It's this sketch. Oh, okay, cool. It's only one sketch, so that will be fine. Yeah, what was I saying? I was saying I was thinking of going a different route at the beginning, where using a 3D printer stepper motor, so something similar to what a 3D printer uses, and then you would have an even more control. But to do that, we would need like an Arduino board connected to a screen that will display the RPM and then a knob, and it was super complicated, so I just ditched the idea. So we said height minus thickness minus what else? Electronic box dot fan offset from top. Cool. Right in the middle. That's it. So everything in gray at the moment is just visual. It doesn't do anything, but it gives me an idea about how it's gonna look like. So for example, I think we need to move the fan a bit downwards. Oh, come on. So maybe fan offset from top 45 would be ideal. Something like that. Still lots of things to be done. Like for example, the power supply. At the moment we only have where's the power supply? We only have the dimensions like left, width, and height. But how are we gonna actually attach it? Oh, and it has a fan. So we need like exhaust also. But I don't have all of these dimensions, so I'm gonna have to wait for it to arrive. Hopefully it will arrive soon. Anyways, what else do we need to do? We have this. I think regarding the visuals, I'm not gonna waste too much time now modeling the bottom part. I was mostly concerned about the motor not fitting or something like that, but now after modeling it, I think it looks cool and we have enough space. And let's see how the entire thing is looking at the